Okay, guys, I think we're going to start. We're going to start searching the universe and understanding what's up in the sky. My name is Dr. Joyce Bluford. Most kids call me Dr. Joyce. I'll be your host today, and we'll be looking at patterns in the sky. We're going to try to understand how we look in the universe and identify things and how that has changed through time. You have to remember the early ancients would use the universe and look at the nighttime sky and try to figure out what was going on. It was a big mystery to them. They didn't have the tools that we have now. They didn't even have telescopes, so they could not see very far. They didn't even realize that planets were not stars. They knew they looked different in the nighttime sky, but they didn't know what they were versus a star. And so through millenniums, we've evolved into trying to understand this universe of ours. Now, this picture that you're seeing right here is do you know what it is? It is starts with a G, it's a galaxy. Now, galaxy is an accumulation of stars, all bound together by gravity. And that's, so you notice they're revolving around the axis. That's called the nucleus. So inside, where it looks bright, that's where a whole bunch of stars are. And when you look into that area there, it's bright in the nighttime sky. Now, this is kind of a model. This is not it looks like our galaxy, which is called the name for our candy bar is named for it, Milky Way. So this is called the Milky Way, but this isn't exactly the Milky Way because we don't cannot get a picture of it from our perspective. So this is another one that we think resembles ours. Now we realize that it has those spiral things going out are called arms. The middle is the nucleus. We will be looking, when we look in kind of like a planetarium show, we will be seeing kind of like a milk spot in the nighttime sky. That's why we're called the Milky Way, because it is a area that when you look into, it looks very bright. And so that's actually when you're looking into the nucleus of a galaxy. And so how we got our name Milky Way. We're looking, so when you see the Milky Way, you're looking toward the center. You have to remember everything in the universe is so relative. Or is it up? Is it down? Is it north? Is it south? Everything is so difficult because of trying to figure out where things are. And this is where understanding these patterns can help identify where you are looking at in the nighttime sky. So, let's kind of look at what is in the nighttime sky. So imagine looking in the nighttime sky for the first time. You can go out, it's been pretty nice out without the clouds, but if you look out there, do you see things moving? Are they rotating? Are they revolving? Where is the sun coming from? If you see like a sharp spark in the nighttime sky, is that a comet? Is it an asteroid? What are these things? And we also want to know what is the universe made up of? You know, why do we care? Well, number one, because humans tend to be very curious, but we also realize that one day we will destroy our planet just by the sheer growth of humans on our planet. So we're always looking for outside just in case we have to colonize. And so that's another thing why understanding the universe really does kind of help out. We also want to understand what resources might be in the nighttime sky. So sometimes when you go out there, just look. Can you tell the difference between a planet and a star? Are they stars going all in one direction where the planets do not? And that the answer is yes to that one. Okay, want to make sure we understand two fundamental movements. One is rotate. Now, you look in this Earth here, rotate means it's going along on an axis. So the Earth rotates on the axis. I notice I also use the word rotate when I was talking about the whole galaxy, and it's rotating around the nucleus. Now, so we have rotation, and what's the other word? Revolution, revolving. So something that goes around something else is revolving. So let's look at this animation here. The sun, does that rotate on its axis? Yes, it's moving also. It's not just up there, stuck up there like, this guy is up here. Not the way it goes. Now, what then revolves around the sun? Well, that's our planets. That's what we call our solar system. It is attracted by gravity, and that's where we have this revolution of planets. Now, if you look at this picture, you notice that one of the planets is ours, which is Earth. So what's going on around it? So the Earth is rotating, but then we are revolving around the sun. Now, what's that other satellite going around the Earth? That is our moon. And it is also attracted by gravity. So you have this system of the larger you are, the more gravity and more pull you have, and the more that things will revolve around you. Does everything rotate in the universe? Yes. There is no way in which there's motion all over the place. Sometimes we don't feel it. Matter of fact, most of the time we don't, but we are moving in space. Now let's take a look of where is this light coming from. Now, what's the difference between a satellite, like a planet, and a star? Who generates their own energy and then emitting light? Those would be stars. They are self-generating. They're producing enough energy to produce light. So stars produce light. But then how do we see things like the different planets in our solar system? The different planets in our solar system are by reflection. So the sun will generate the light. It then reflects off a certain objects. So if you look at Venus and Moon right here on the right-hand side, you can see that that little crescent there is being a reflection. So planets, asteroids, things that do not generate their own energy can be seen by reflection. That, imagine being an ancient and looking in the nighttime sky, not understanding it. Just to even think about the moon. The moon, you don't see it all the time. Why does it go through these different patterns? And it did take a lot of people a long time to figure it out. Now, what is the universe made out of? Mainly, it is hydrogen and helium are our major components. And now notice that says 99% is plasma. Well, what in the world is plasma? Plasma, and don't confuse that. They use the word plasma for blood. That's not the same word. It's the same word, but does not have the same meaning. Plasma is stripped electrons. So you have a lot of hydrogen and helium in the form of plasma all over the universe. At one time, we thought that there would be no color out there, but plasma is, and most of you probably have seen a plasma ball. It has this shimmering light. So let's take a look at the periodic table. Now, the periodic table, notice you have, find hydrogen for me. What's its atomic number? You can see it's number 1. And where is helium? Go across, and helium is number 2. Now, if you notice, these are the fundamental elements found throughout the universe, but from every other element comes from hydrogen and helium. These are your kind of like mother molecules, and from those you can almost form everything else in the universe. Now, in the universe also, we have carbon can be found. And you can find many other gases up there depending on where you are and how good your gravity is to hold things together. Now, so realize that on Earth we have all these elements, but in the universe, hydrogen and helium are the key components. Now, so let's look at the individual unit of the star, because the star is really our unit. Now, and many times we didn't know about what the stars actually meant. So we want to take a look at how the evolution of scientists, and astronomers are usually people who study kind of stars. Astrogeologists would be people who study like the surface of the planets. Now let's look at the many colors. Let's start with our own sun. What's the color of it? It's mainly yellow, orange, and it's considered a main sequence star. But then we also have other colors that we have identified. One is like a blue giant. It seems like blue stars are much, much larger than our sun. We have things like white dwarfs. And we found that there's many shapes, many sizes, and many colors. Now, what do these colors possibly mean? Well, if you look at our data chart in the upper right-hand corner, can you go through with me and try to determine which is the hottest stars and which is the coldest stars? Now, don't think of, a lot of times on Earth, we think of red as hot, but is it on this data chart? No. So if we look at a red star is from 3,500 to 3,000 degrees Kelvin. Now this is still very hot. You wouldn't want to touch it or anything. But notice the different stars. And if you notice in the left-hand side of it, it has O, B, A, F, G, K, M. These are ways in which astronomers, when they're plotting new stars, they give them a color. So they can start seeing patterns. And this is the whole idea of today's lecture, is to understand that in order to understand all about this, you had to collect data, you had to put it on a chart, and then you had to interpret that chart. Now, if you look in the lower left hand, it's called a Hertzsprung-Russell chart. Now notice when they started plotting them, do you start seeing some kind of pattern? Now notice on the bottom you have the spectral class. That refers to kind of the color. The absolute brightness means that how bright it really is, not to our eyes, but really how big that star is. And then the temperature is up on the top. When you have this threefold graph, all of a sudden we have some information. And this is two scientists, Dr. Hertzsprung and Dr. Russell, came up with this main sequence stars. So the ones kind of like in the middle area that kind of go through the whole kind of graph. These are your main sequence. So when we were talking about our sun being a main sequence, we would be in the region with the yellow and orange area. And so when you start plotting them, you start figuring out, well, are blue stars all old? Are red stars all young? What does this mean? And so they started with this basic information and then started every time they would have a star, they would try to plot where it is to try to figure out, can we tell anything about the evolution of these stars? Because you have to remember, it's these stars that are twinkling up in the sky, and those are providing the pattern to really understand. Now, let's take a look at how we actually explore space and collect this data. Now, Hertzsprung and Russell really could not have developed their charts unless they had a way of figuring out these colors. In the 70s, they put out the Hubble telescope. Now, you have to remember the telescope was not invented until Galileo. This is, far long, long time ago, but their telescopes only could see kind of dots. They never really could see, they could see the surface of the moon because we have something around our Earth called the atmosphere. And when we're looking straight out, that atmosphere distorts actually what we see in the whole universe. And so this instrument called the Hubble telescope, and I remember when it first went up there, we were all excited about finally getting some pictures and finally kind of understanding how these stars might evolve. So the Hubble telescope is still out there, still providing us information as it is a satellite going around our Earth and still giving us information. But it is this Hubble telescope that has provided with some of the clearest pictures and understanding of our universe. Now that was kind of dramatic, huh? And what it is if you notice that there was revolving around the axis, this was all this kind of plasma that gravity starts pulling together. Gravity then starts making these elements. Now, before Hubble, we did not know that stars are being born today. Now, this very famous picture of the Eagle Nebula is a star nursery. And if you can just imagine that swirling that you've seen, this is going around, and these little bright spots that we're seeing are actual stars. So a star can then be born in certain areas. We now know that nebulars for a long time were just considered high concentrations of plasma and hydrogen and helium, but we didn't really understand what they were doing. So our nebula basically is where our stars are born, mainly through gravity. And this Eagle Nebula, if you could just imagine those pillars, and these were given this very famous picture, I think this is called the Pillars of Life, is just how the gravity then starts pounding and putting these molecules together and forming these stars. Now, just think, guys, if you can be born, what is the opposite of being born? You die. Do we have stars that die? Of course, you have stars that are dying. This is when there's not enough hydrogen and helium to maintain the creation of the brightness, and it forms this area where a star dies. And guess what that is in the middle here? We now know that the center of a dying area or star is then called a black hole. This is where we experience super gravity. And so everything kind of gets sucked in. And so when a star becomes unstable, doesn't have enough hydrogen and helium to perform its functions of generating molecules, it then burst on itself. And that's what we call a dying star. Now, in this area here, we know it's high gravity. Some people have theorized that there's a whole nother universe on the other side. We do not know what's on the other side. Is there time on the other side? What is actually going on inside this intense gravity? There's lots and lots. That's what a theoretical astronomer, a theoretical physicist, this is what they start trying to understand. They collect the data from the scientists who prefer to collect data, and they try to figure out what is going on. So a star can be born and a star can die. Now there's many other objects in the universe. Now, these are all, they're called nebulars, pulsars, expanding bubbles, and then we give them silly names because we did not know what they were kind of until recently. So let's take a look at a Crab Nebula. That means this is probably an area of new birth. And then if you notice, it has it had kind of that just little pulse. That was what we have pulsars. We have all these kind of funny sounds that we hear from Earth. Then we have things called the expanding bubble. As you're getting closer to this thing, these are pictures that are just unbelievable. And as we get more satellites up there, we're getting clearer pictures. And then, of course, the cat's eye. Everybody loves that one because it looks like a cat's eye as you come in here. And this is also a nebula, a source of this hydrogen and helium. Now, let's go back to our Milky Way. This is, again, it's not a picture of ours. We cannot take our own pictures, but our galaxy is mainly made up of young intermediate stars. That's why, remember, in the Hertzsprung-Russell chart, we were a main sequence. Now, if you look in the middle here, what did I call this before? Starts with an N, nucleus. So this is a high concentration of a lot of stars. We are a spiral galaxy. If you remember, the arms were spiraling around. Now, where do we live as our solar system? We're actually in one of the arms on the outside. So that's why when we look this way, we see the, what did I call it? Like a milk stain. That's when we're looking into the belly of the nucleus. If our eyes are looking this way, we would not see that milk stain. Now, let's kind of take a look at some of these patterns. And let's kind of go back through time to try to figure out what did they see. They didn't know what they were, so of course you make up stories. They knew that it probably was powerful, so they would give it certain names and status, like Jupiter and Zeus and all these fantastic stories. Now, are these stories important? Well, in a way they are, because it started for us to realize who was creating these stories and who was interested and what it might have meant in the society. So we're going to be looking at the Northern Hemisphere now, and I'll explain that in a little bit. But I want to have this song so you can kind of understand the term constellation. Now, constellation is just a pattern of stars, might not even be in the same galaxies. It is what humans see when they look in the sky.
Wouldn't it be heavenly to know the constellations, scan the skies and recognize their names and their locations, though they're only figments of our own imaginations? Wouldn't it be heavenly to know the constellations? Hercules, Delphinus, and Andromeda, and Lyra, Pegasus and Sagitta, Dorado and Lacerta, Ursa Major, Ursa Minor, Cetus and Orion. I could name a dozen more if I were really trying. In the zodiac you'll find a dozen constellations. You can trace them in the sky with just a little patience. Leo, Virgo, Scorpius, and Gemini and Taurus. These are 5, now who can name the other 7 for us? Aquarius, Sagittarius, Aries, Libra, Capricorn, Cancer, Pisces. What determines what we see among the constellations? Atmosphere, the time of year, as well as their locations. Latitude and time of night are prime considerations. Each of them are factors when we see the constellations.
Now that's just a fun little song on the different constellations. Now remember, we're living in the northern hemisphere. We see what's above us. If you're a child in Australia, would you see the same sky? No, that's the southern one. So if you look on the right-hand side there, the star patterns are different. Are the myths different? Yes. Now, today, we use, so let's take a look right here. We're going to concentrate, of course, on the northern hemisphere because this is what you can see. But so the constellation, that constellation song came from the northern hemisphere. It mentioned Ursa Major. It mentioned, what else did it mention, guys? Let's see around here. Draco the dragon, the Big Dipper, Cassiopeia. There's all these wonderful stories. Which one is that? That's Pegasus. Aha, we have Aries. Now notice it mentioned Pisces the fish, Taurus the bull, Orion, Gemini. Now they gave these guys special names: Cancer, Leo, Virgo. Not showing there. These were the zodiac. Now, sometimes they'll ask you what sign you were born under, and that's the zodiac signs. But in the past, that was a very important group for people in the Northern Hemisphere because they could start telling the seasons when they should start putting their seeds in the ground. It was very, very important. So the suns, I mean, or these patterns actually helped the humans to understand what was going on. Now, so the myths are these stories that they would use. Now, just think if you were a kid, what would your job be 2,000 years ago? You wouldn't have had television. When you have iPhones, all at night, what would you have? You wouldn't have electricity. You would just look up in the nighttime sky. And what would you do? You'd make up stories. You'd start talking about maybe the human interaction of these stars. And that's exactly where these myths evolve. And so that's why these myths have become important. But today, in astronomy, there is 88 constellations. Now, wait a minute. Why is there 88? That's because it's a way in which astronomers can break up our globe. Now, let's take a look at, I have a globe here. Now, notice what's inside here, guys. Inside is the Earth. So the Earth is looking outward. And so this pattern, this sphere, is then divided into 88 groups. And they're given constellation names with the constellation that's the most prominent in there. And this allows astronomers for us to look up into the nighttime sky and realize what we're looking at. So if you're looking at Ursa Minor, you're looking straight up at what we would call the north. So this is an important way in which something that was based on agriculture and storytelling or myths turns into an astronomical use. Now, the signs of the zodiac, we're going to see how they played an important part in understanding how the seasons kind of evolved. Because it's not, right now we have calendars. If you've ever studied how calendars evolved, it took humans thousands of years to come up with a calendar and to try to figure out how it will impact our lives. Okay, so let's go back. Now also here, this is, which hemisphere is this? This would be the southern hemisphere. So if you're looking at this, it would be down on the, down under, as we call it. Now here, the equivalent, they have the Southern Cross, which is kind of going due south. Okay, so Okay, so let's take a look at these patterns again. So I just described it, want to make sure you understand. So the northern is this one right here. So these are pictures of do you guys recognize these? This is the Little Dipper. This is Polaris. That is our North Star. It was very, very important for sailors at night. Imagine being out on the water, not seeing land. How would you know how to navigate? These are where these stars um, for shippers would really have to understand their um, their suns or their star patterns. Okay, now we're going to go back to Earth. Now let's look at the southern. Now this is the Southern Cross. So this is looking directly like due south. So this would be the equivalent. We look at Polaris or our North Star, like here in Fremont. It would be looking kind of northern. Um, and this is the Southern Cross if you're down under. Okay, now these stars show patterns, and it's these patterns that the ancients created these stories. But let's kind of understand, now if you notice right here, what's coming up right here? That is a bear. That's Ursa Minor and Ursa Major. I'll tell you a story about theirs because a lot of these myths are kind of fun. Now, a lot of times when we teach this, we have the kids look in the planetarium or look in the nighttime sky and try to figure out what kind of pattern. We've gotten some really cool stories about the constellations that they see if you were a child today. You have to remember almost all of these myths are based long, long ago. Okay, so, well, actually, I'd like to read a little story about the bear and the baby, because this is one of the most important constellations for us in the Northern Hemisphere. It's what helps you get unlost if you want to find north. So here we go. So this star right here would be, what did I say is the name of the North Star? Polaris. And this is the Little Dipper and the Big Dipper. Now that's called, the Big Dipper and Little Dipper are not formal constellations. They are part of Ursa Minor, the baby bear, and Ursa Major, the mommy bear. So I want to make sure that that's kind of clear in your head, is that it has to do with the patterns that we see. When the sun goes down, most people in my village go home. They fear the dark. One night I walked to the village storyteller called Abraham, who lived near the large tree. He can always look to the heavens and see strange shapes and stories. I huddled next to my friend to hear the next exciting story, a myth about Jupiter, the king of the Roman gods of long ago. Look to the skies and you could see a very bright star. It is Polaris, the North Star, which helps sailors to find their way at night, he began his story. Abraham pointed to the northern part of the sky and said, "Follow the stars as they outline a Little Dipper and then the Big Dipper. These are the tails of two bears, Ursa Minor and Ursa Major. This is a tale of a bear and a baby." Guys, think, today's bears, do they have long tails or short tails? They have short tails. Oh, maybe back then they had long tails? Let's find out. One day Jupiter was sitting on his throne and saw a beautiful maiden named Callisto, who worked for the warrior Diana. Jupiter fell in love with Callisto, but he was already married to Juno, a very powerful goddess. This was a problem. Jupiter changed his appearance to Diana so he could meet Callisto. They talked and talked. Juno had no idea what her mischievous husband was up to. Abraham shook his head to show his disapproval. Jupiter, thinking that Callisto would like him, changed his appearance back to Jupiter. This frightened Callisto. Meanwhile, Juno was still unaware of her husband's actions. Jupiter fell in love with Callisto, and they had a baby together. Then Juno found out and blamed Callisto. Juno punished her for turning her into a bear. The baby boy Arcas was left in the forest. A kind old couple found him and raised him as their own son. He grew into a handsome young man that loved to hunt. Callisto the bear lived in the forest and would protect Arcas when he hunted. Arcos did not know this bear was his mother. He wanted to be near her son, but got a little too close. Did you notice how long the tail was? It was short. Abraham's voice got louder. Arcas was just about to kill his mother when Jupiter, who created this mess, decided that he would change Arcas into a baby bear so Callisto could safely be with her son. Jupiter was fearful that Juno would discover. Okay, I can't see that. Can't discover it, so he hurled them up into the nighttime sky. And what happened was it got your Ursa Minor, the baby bear, and Ursa Major, the mommy bear. But he hurled them, and that's why the tail grew. Sorry, I'm not sure why the. Abraham ended the story with a sigh of relief. They are together forever as two famous constellations. Now notice this is just a kind of a silly little story, but it's no different than our silly kind of stories where we talk about people who love somebody and then is unfaithful. It's the same kind of humans are always gossipy and like to make these stories. So a lot of these stories have to do with human interaction. And of course, they would be called gods and goddess if they were up in the nighttime sky. But this is a way in which you can remember where Polaris is. But remember, it is the constellation Ursa Minor and Ursa Major. The Little Dipper and Big Dipper are called asterisms. They're part of a constellation. Okay. Now, let's go back to our patterns and let's see what it might have meant through time. Okay, now, we know that there's many of these kind of temples throughout the world that when the sun is at a certain area in the sky, that it projects light. So these are some of the different temples that you might see. This is in Peru. These here, it will line up. This is 2,500-year-old solar observatory. They were always trying to position the sun because remember I told you the sun revolves and rotates, but it moves through the nighttime, through the sky. It's never in the same place. And recording where it is has been kind of important. So let's take a look at these again. This is probably the most important one. I've noticed that they've had some information about Stonehenge. When they recreate it, these little, it can actually, it's a calendar really, and it really can start telling you what time of the year it is. So these used monoliths that you find in certain areas had something to do with understanding our solar system. Now, the constellations of the zodiac. Now, I've used that word before, zodiac. Usually, you know, now you could, what's your sign? That's kind of more nonsense than science, but it's kind of fun too. But what is this sign of the zodiac? Now, does the sun come up in a different area? Here in Fremont, where does it come up? Does it come on what side of Mission Peak? Now remember, we're in February right now, so we've finished the winter solstice, which is the point in which it's the lowest. The solstice is December 21st, and then June 21st would be the highest. Now let's take a look. So let's look at December 21st. So we'd come on what side? So notice on June 21st, it's coming up high. It's on what side of Mission Peak? It's going to be on the north side of Mission Peak in the summertime. Now, how about in December 21st? It's at the lowest. So right now, December 21st, just before Christmas, it was at its lowest part in the sky. And you'll notice that it'll start raising, raising, raising up. This band in the sky is called the zodiac. And it is the constellations that you find in the zodiac that define a time where you can start growing things, especially. This was an important part of understanding. That's why the signs of the zodiac became very, very important. Now remember, this only works in the northern hemisphere, not the southern hemisphere. So the southern hemisphere, that's a whole nother kind of history of figuring out what time of the year it is. So let's kind of take a little closer look to this. So here we have, just so you see the background, the revolution of the Earth around the sun. And then these signs you can start seeing at a certain time of the year within that band of the zodiac. That's why these became very important. And then it evolved into astronomical signs, you know, where you were born and all this stuff. So these are specifically 12 signs representing 12 months of the signs. So they're kind of fun to know what sign you were born under, but for now, they're just kind of for fun. So that's the signs of the zodiac. Now, let's take a look at the nighttime sky. Now, this is as if we do have a planetarium here. And usually what we do when we go up there, we turn the lights off. I want to impress upon you guys that is there stars up there now? Yes. But because the sun is out, we can't see them. Now notice, this is what star, the Polaris. And notice everything is kind of going around its axis on there. And so that's why Polaris is important, is because the ancients noticed that it didn't seem to move. So that means it was part of that axis. Now notice as the sun comes up, you don't see the stars as much. So in our planetarium, you could start seeing how these guys evolve. Now, notice that we do have the names of them. Now, also notice the Milky Way, which is right in here. It's a kind of that milk stain. And this is where you can start seeing these patterns. But notice how they're moving, and they can create an area that you're looking toward, Ursa Major, Polaris.
Right in between the Big Dipper and Little Dipper, you always have the tail of Draco the dragon. So again, it's a way of just dividing up the sky. So if you want to try to find other planets or star features, you can do that. Okay, back to Joyce.
Okay, guys, so we have two activities for you, again, looking at these patterns. Now, one is, now Ursa Major and Ursa Minor are always in the sky, but you only can see them at dark time. And so we have a little activity here where you can make your own time and figure out what to do. So, you need the worksheets, which is online, scissors, crayons, and brads. So Phoebe will explain how to make these.
Today we're making a star dial of Ursa Minor and Ursa Major. So you're going to take your worksheet, which looks just like this, and color in the different months with markers or colored pencils or crayons. So once you have that, you're going to grab your scissors and you're going to cut out the two circles. So you're going to see this. And you're also going to want to cut out this little window. So on the worksheet, it says the words cut. So you're going to cut that out also. So you have 2 circles. And then you're going to lay them on top of each other with a smaller one on top. And then we're going to grab a brad and poke it through the middle of both of them. Just like that. And then flip it over and press the 2 sides of the brad down so it's secure. Now when we flip it over, you can turn it. Just like that.
And the coloring is mainly so it's easier to see at night. Now we also have another one that's more of a general star finder. And this is a if you want to find the zodiac in the nighttime. So these are prepared using another worksheet that we have online. If you want to find when the zodiac, especially your own, is up on time. So here's Phoebe again.
Today we're making a constellation finder. So you have your worksheet that looks like this. And you're also going to need a piece of construction paper that's 5.5 by 5.5 inches long. So first we're going to color in the wheels here. You can use markers, color pencils, whatever you have, and just color in the months, and you can put your own special designs on it. So next we're going to cut those out with a pair of scissors. I'm going to cut out the circle and this square shape over here too. So once you have that, it's going to look like this. And we also need to cut out this oval right here. So how we're going to do that is you're going to fold the paper and then use your scissors and cut into the white space, the oval here. And then once you have that cut made, you just use your scissors and cut to the edge. And then you're just slowly going to cut around the edge with your scissors like this. And then you're going to go all the way around until you have an open space like this. And then once we have our open black piece with the oval cut out, we're going to take that and lay it on top of our square construction paper. So you're going to line up the corners like that so it fits nicely. And then we're going to use a stapler and staple along the edges where it says staple, right over here. So we're just going to secure this black sheet of paper to the construction paper. So it looks like this. And then we're going to take our wheel and just slide it into the pocket, just like that. And now you can turn it and find your constellations.
Now you could take this with you at night, but make sure you have like a little flash light. Red light tends to be better so it doesn't ruin the nighttime sky. But this is where you start looking at the skies itself. Okay, so let me clear this out and let me escape.
I will remind everyone, when you're using those star finders, you hold them up over your head. So it's made so that you can find the month and day. It'll give you an exact kind of view of what you should be seeing. And again, if you use a flashlight that has kind of a red cover, red plastic or red cellophane, then that won't destroy your night vision. So when you're used to looking up at the night sky and your eyes have adjusted to the darkness, you'll still be able to see those patterns. Okay, Dr. Joyce.
Okay, so guys, I hope this is just basically an introduction. Astronomy is a very large field, lots of data collecting and interpreting it.